When we look at the ruins of the Roman Empire today, our eyes are immediately drawn to the giants. We see the colossal skeleton of the Colosseum, the soaring dome of the Pantheon, or the triumphal arches that celebrate long-dead emperors. We see the marble, the statues, and the sheer scale of their ambition. However, these famous monuments are essentially just the decorations of the empire. They are the visible skin of a much more complex organism. If you were to strip away the marble and the temples, you would find the true secret to Rome's dominance, a vast, intricate, and often invisible machine that kept 60 million people alive, fed, watered, and ruled from a single city. We are speaking, of course, of the hidden infrastructure of the Roman Empire. This is not merely a story about piles of stones. It is a story about the internet of the ancient world, a network of roads, hydraulic systems, supply chains, and bureaucratic organizations that shrank the world and allowed a pre-industrial civilization to function with the efficiency of a modern state. Today we will peel back the layers of history to reveal how this machine actually worked. We will examine the subterranean sewers that are still in use today, the supply lines that turned the Mediterranean into a Roman lake, and the engineering marvels buried beneath the earth that allowed Rome to last for 1,000 years. Please make sure to watch until the very end, where we will discuss why modern engineers are still struggling to replicate the longevity of Roman concrete, and what that failure tells us about our own civilization. To understand the magnitude of this system, we must first look at the origin of the problem it solved. In the early days, Rome was merely a collection of hilltop villages overlooking a swampy valley. As the Republic expanded, it faced a logistical nightmare that no previous civilization had successfully conquered on such a scale: the tyranny of distance. How do you govern, tax, and defend a territory stretching from the misty hills of Scotland to the burning sands of Syria without telephones, trains, or computers? The Persians had roads, and the Greeks had ships, but none had attempted to integrate the two into a standardized, reliable system. By the time of the Emperor Augustus, Rome was a city of perhaps 1 million people. This was a population density that would not be seen again in Europe until Victorian London. A city of that size is a hungry beast. It consumes thousands of tons of grain, millions of liters of water, and generates mountains of waste every single day. Without a mechanized infrastructure, Rome should have collapsed under its own weight within a week. The fact that it didn't is a testament to the invisible solutions they engineered. The first major challenge was movement. If an army cannot move, it cannot fight. If grain cannot move, the people starve. Thus, the Romans developed the foundation of their infrastructure, vie publicae, or public roads. You have likely heard that all roads lead to Rome, but we must look closely at how they were actually built to understand why they survived. These were not simple dirt tracks cleared of trees. They were multi-layered engineering projects that required as much calculation as a modern highway. We will start from the bottom up. Roman engineers, often working with legionary labor, would dig a trench, the fossa, down to the bedrock or solid soil. Inside this trench, they laid the statumen, a foundation of large, heavy stones. Above this came the rudus, a layer of smaller stones mixed with lime mortar to create a solid, watertight seal. Next was the nucleus, a layer of gravel and sand, and finally the pavimentum, the smooth, interlocking polygonal stones we see in tourist photos today. This layered approach provided drainage and shock absorption. When a legion marched, thousands of hobnailed boots hammered the surface. A rigid road would crack, but a layered road absorbed the impact. Furthermore, these roads were cambered, curved slightly so that rainwater would flow off into side ditches. This seems simple to us, but in the ancient world, a road that did not turn into a mud pit during autumn rains was a strategic superweapon. It meant the Roman state functioned 365 days a year, while their enemies were often stuck in the mud. Can you imagine what would have happened to the Roman conquests if their armies had to wait for the ground to dry every spring? It is likely the empire would never have expanded beyond Italy. However, a road is useless without a system to organize who travels on it. This leads us to one of the most brilliant organizational inventions of the empire, the cursus publicus. This was the state-run courier and transportation service established by Augustus. It functioned similarly to the Pony Express or a dedicated railway line. Along the major roads, at intervals of about 10 to 12 miles, the Romans built mutatanies, or changing stations. Here, a courier could swap a tired horse for a fresh one without stopping. Every 20 to 30 miles, there were mansiones, essentially state-run hotels where officials could sleep and eat. This system allowed intelligence and orders to travel at a speed of roughly 50 miles per day, and in emergencies, much faster. While this sounds slow to us, in the ancient world, it was light speed. It meant the emperor in Rome could react to a revolt in Gaul weeks before the rebels expected a response. This infrastructure of information was just as vital as the stone roads themselves. It bound the provinces to the center, creating a psychological sensation that Rome was always watching, always present. While roads connected the empire horizontally, another system connected it vertically, the hydraulic infrastructure. We must turn our attention to the lifeline of the city, water. Rome's obsession with water was not just about survival, it was about cultural superiority. A civilized Roman expected to bathe daily, flush their latrines, and drink from fountains. To achieve this, they built the aqueducts. But the genius of the aqueduct is not just in the famous arched bridges like the Pont du Gard in France. The true genius lies in the hidden surveying and the subterranean tunnels that make up the vast majority of the system. Most of a Roman aqueduct is actually underground. This was done for protection, to keep the water cool, free from pollutants, and safe from enemy sabotage. The engineering challenge here was maintaining a precise, consistent gradient over dozens of miles. The water moved by gravity alone. If the slope was too steep, the water would rush too fast and erode the channel. If it was too shallow, the water would stagnate. Roman engineers, using tools like the chorobates, a leveling instrument, and the dioptra, achieved gradients as slight as a few inches per mile. Consider the Aqua Marcia, one of the longest aqueducts supplying Rome. It traveled over 90 kilometers, about 56 miles, from its source to the city. The calculations required to ensure that water arriving from the mountains would end up at the exact right height to flow into the city's distribution tanks are mind-boggling, especially without modern optics or digital computers. Before we move on, pause for a moment and write in the comments, how long do you think it would take a modern construction crew to build a 50-mile tunnel through mountains today? And do you think it would last 2,000 years? Once the water reached the city, it hit the Castellum Aquae, a massive distribution tank usually located at the highest point of the city geography. From there, lead and terracotta pipes branched out like capillaries. This brings us to a hidden system that is often overlooked: the pressure handling. Rome's topography is hilly. To get water across a valley without building a giant bridge, they sometimes utilized the inverted siphon principle. They would run pipes down one side of a valley and up the other, relying on the pressure built up on the descent to push the water up the ascent. The pipes for these siphons had to withstand immense pressure, requiring high-quality lead soldering and thick walls. This immense inflow of water necessitated an equally impressive outflow. You cannot pump millions of gallons of water into a city without a way to remove it. This leads us to the Cloaca Maxima, the greatest sewer. Originally an open-air canal built by the early Etruscan kings to drain the swamp that became the Roman Forum, it was eventually enclosed and expanded into a massive underground tunnel system. The Cloaca Maxima is a testament to the less glamorous side of civil engineering. It was large enough for a wagon loaded with hay to drive through. It took wastewater from the baths, runoff from the streets, and sewage from the public latrines and dumped it into the Tiber River. This brings up an important point about the hidden social logic of the infrastructure. The Romans did not understand germ theory. They did not build sewers primarily for hygiene in the modern sense. They built them for water management and odor control. The fact that it helped reduce disease was a happy accident, though not a perfect one, as Rome was still a disease-ridden city by modern standards. We must also examine the hidden infrastructure of logistics, specifically the annona. This was the state-sponsored supply chain that fed the city. Rome required hundreds of thousands of tons of grain annually, mostly imported from Egypt and North Africa. To handle this, they turned the Mediterranean Sea into a conveyor belt. But ships need harbors, and nature did not provide Rome with a good one near the city. So, the emperors Claudius and Trajan dug one out of the earth. We are talking about Portus, located near Ostia at the mouth of the Tiber. This was an artificial harbor of colossal scale. Trajan added a hexagonal basin, a shape chosen specifically for efficiency. A hexagon allows for more ships to dock simultaneously than a circle or square, and it breaks up the waves to ensure calm water. Around this basin were massive warehouses, or horea. These were not just sheds, they were designed with raised floors to allow air circulation and prevent dampness from spoiling the grain. The walls were thick to keep the interior cool. The organization required to manage Portus was staggering. Every amphora of olive oil and every sack of grain was weighed, stamped, and recorded. We have found millions of broken shards of these transport jars at Monte Testaccio in Rome, an artificial hill made entirely of discarded olive oil containers. This hill stands 35 meters high and contains the remnants of an estimated 53 million amphorae. It is a monument to ancient consumerism and waste management. It shows us that the Romans had a disposable packaging industry just as we do, although theirs was ceramic rather than plastic. Now, let us speak of the materials that made this possible. The secret weapon of Roman infrastructure was, without a doubt, opus cementitium, Roman concrete. While we use concrete today, the Roman recipe had a special ingredient, pozzolana, a volcanic ash found near Naples. When mixed with lime and seawater, this ash caused a chemical reaction that created an incredibly durable bond. In fact, Roman marine concrete actually gets stronger over time when exposed to seawater, thanks to the formation of a rare mineral called tobermarite. This material allowed them to build where others could not. They could pour foundations directly into the ocean to build breakwaters for their harbors. They could cast massive vaulted ceilings, like that of the Pantheon or the Baths of Caracalla, covering vast interior spaces without the need for a forest of supporting columns. This revolutionized architecture. It moved the focus from the external appearance, like Greek temples, to the internal space, the shaping of air itself. But who built all of this? The labor force is the dark, hidden engine of the empire. We often imagine slaves building everything, and indeed, the brute labor in the quarries and the mines was performed by enslaved people living in horrific conditions. However, the highly technical work, the road building, the bridge construction, the aqueduct maintenance, was often the work of the Roman legions. The Roman soldier was as much a construction worker as a warrior. He carried a shovel and a pickaxe alongside his sword. When a legion wasn't fighting, it was building. This served a dual purpose. It kept the soldiers physically fit and too busy to mutiny, and it expanded the infrastructure of the state at a low cost. The soldiers were already being paid. Having them build a road was essentially free labor for the state. This militarization of infrastructure meant that Roman engineering had a standardized, disciplined quality. A bridge built in Syria looked remarkably like a bridge built in Spain because the same army manuals and training were used. We must also briefly touch upon the hidden systems of heating. If you were a wealthy Roman living in a villa or visiting the public baths, you walked on warm floors during the winter. This was the hypocaust system. The floor was raised on stacks of tile or brick pillars, and hot air from a furnace was circulated underneath. Hollow tiles in the walls allowed the heat to rise, warming the room from all sides. It was a central heating system that was cleaner and more efficient than the fireplaces used in Europe for 1,000 years after Rome fell. Stay with us, because we will return to the question of why this technology disappeared later. A question naturally arises. If this infrastructure was so superior, why don't we build like the Romans today? Why do our roads have potholes after 5 years, while the Appian Way is still passable after 2,000? There are several reasons, some technical and some economic. First, we simply cannot afford to build like the Romans. The Roman roads were immensely thick, sometimes 3 to 5 feet deep of stone and aggregate. Modern roads are a fraction of that thickness. To build a modern highway with Roman density would cost astronomically more than our economies could sustain. We build for a lifespan of 20 to 50 years because it is cheaper to repair later than to build for eternity now. The Romans, lacking our economic models and driven by a desire for eternal imperial glory, front-loaded the cost. Secondly, there is the issue of survivorship bias. We see the aqueducts and roads that survived. We do not see the thousands of poorly built Roman apartment blocks, insulae, that collapsed and killed their tenants, or the roads that washed away. We look at the best of their engineering, not the average. However, there is a chemical difference as well. We mentioned the volcanic ash in their concrete. Modern Portland cement is designed to dry quickly so we can build fast. Roman concrete took a long time to cure, sometimes months or years to reach full strength. In our modern world, time is money. We cannot wait 6 months for a wall to dry. We traded longevity for speed. Ultimately, the hidden infrastructure of Rome teaches us a profound lesson about civilization. The Romans understood that a true empire is not held together by fear alone, but by utility. By making life easier, cleaner, and more predictable, they made subject peoples buy into the system. A Gaul might hate the Roman conquest, but he loved the road that let him sell his wine, and he loved the aqueduct that brought water to his town. This infrastructure was a mechanism of assimilation. It standardized the world. The same weights and measures were used in London and Alexandria. The same width of cart axle was required on the roads. It was an early form of globalization. Today, as we face our own infrastructure challenges, crumbling bridges, aging power grids, and the need for sustainable building materials, we are looking back at Rome. Scientists are currently analyzing the chemical structure of Roman marine concrete, hoping to reverse engineer it for use in rising sea levels. We are studying their passive cooling systems in architecture to reduce our reliance on air conditioning. The Roman Empire may have fallen, but the skeleton it built remains. The layout of London, Paris, and Cologne is still dictated by the Roman planners who laid out the streets. The train tracks of Europe often follow the exact routes of the Roman legions. The hidden infrastructure never really went away. It just became the foundation of our own world. So, the next time you turn on a tap, drive on a highway, or send a package, remember that the systems making it possible have their roots in the mud and stone of ancient Italy. We are, in many ways, still living in the shadow of Rome's engineers. Now, I want to hear from you. We discussed the immense human cost of this infrastructure, the slavery and the forced labor. Do you think the architectural achievements of Rome justify the suffering required to build them? Or is it impossible to separate the beauty from the brutality? Write your thoughts in the comments below. If you enjoyed uncovering the secrets of the ancient world with us, please make sure to like this video and subscribe to the channel. We have many more journeys into history planned, and you won't want to miss them. Thank you for watching, and we will see you in the next documentary.